Astronomers are calling it the most important delivery of the decade at Canada-France-Hawaii Telescope.
So today's delivery of Spiru was an unexpected surprise. We had planned on delivering it, but it looked like the weather was going to cancel us. We totally lucked out. The driver was able to drive up because of his skill as a driver.
On January 26th, during a small window between the snow flurries atop Mauna Kea, the observatory's newest and most advanced instrument arrived.
There were a lot of challenges in getting it up here in weather form. Mother Nature wasn't agreeing with us. She gave us a peekaboo of sunlight, and after that we had nothing but clouds. It's exciting to have a new instrument here at CFHT. We haven't had one for a while. We had Satel the other year, but no, it's very exciting.
And now we've been able to uncrate 2 of the 13 boxes that houses Spiru.
Spiru is now being unpacked and reassembled. It's a delicate process that will take a couple of months.
Spiru is a spectrograph. And what that is just a fancy word for something that splits the light up into its rainbow, and we can tell a lot of things about the stars from that rainbow. But one of the main things that Spiru will be able to do with this rainbow is tell us about whether there are planets around a star or not. And that's very exciting for a lot of people right now. We have some of the first chips of this kind ever made in the world. This is very brand new technology, and we're excited to be using it.
Once it's reassembled, the instrument will undergo testing in the lab and on the sky before being declared ready for science.
Spiru is a game-changing instrument because this is technology that hasn't been used before and isn't being used anywhere else in the world currently. Right now, when we want to look at planets, we look a lot in optical, light that our eyes can see. Spiru is going to look at all of the infrared light visible from Mauna Kea, which will give us a completely new window and help us to discover new planets that we currently can't find. It's an instrument that's going to completely change how we look for planets. It looks at really cool red stars, so we have to look at a different color of light, the infrared, and we should be able to detect planets that are similar to the Earth, just around a different kind of star, a cooler, smaller star. The real-world implications of Spiru are diverse, and we're actually not sure of all of them yet. Any time that we take a leap forward in the kind of camera technology like we're doing for Spiru, the knockdown effects are phenomenal. You know, for example, CCD imaging in astronomy is one of the reasons that we all have cameras in our phones nowadays. So we're really excited to see what the technology that is being used in Spiru ends up being seen later on down the line for the public. Spiru is also going to be answering one of the biggest questions that people have had since the very beginning of time. Are we alone? Are there places in the universe where life can be harbored? One of the main science goals for Spiru is the search for habitable planets. Habitable planets means life, and so we would love to see Spiru discover the very first planet that could be habitable. We'll need the next generations of telescopes to tell us more details about those planets, but we hope that with Spiru we can have a list of potential planets where life could exist.
Canada-France-Hawaii Telescope anticipates Spiru will see first light in spring 2018.
Mauna Kea and Spiru go hand in hand because of the dryness of the mountain. Spiru, looking in the infrared, needs really, really dry conditions, those that are seen on Mauna Kea and almost nowhere else. There's also superb image quality. Our stars that we look at Spiru are going to be round, they're going to be circular, and the air above it is going to be cool and dry, which only gives us the best data possible.